So we're going to talk about solving one-step equations and this time we're going to talk about using or with multiplication or division. So before, you should have done solving one-step equations by adding or subtracting. Now we're solving one-step equations by multiplying or dividing. And it's very similar. We just need to ask ourselves what's happening to our variable and undo that. We still follow all the rules of algebra. So if I start with, let's say, q over 7 equals 2, I ask myself, what is our variable's name? It is q. What is happening to our variable? And I know this looks like a fraction, but that's really a division symbol. So we say q is being divided by 7, and the inverse of dividing by 7 is multiplying by 7. So I'm going to do that on the left side, and I'm going to do that on the right side because I'm following my rules of algebra. I do the same thing to both sides. Now I multiplied by 7 on the left side, so that way that could go poof and make that go away. And then I have q equals 2 times 7, which is 14. And that's it for dividing. It's really simple. Let's look at another one. How about 3 equals p over 2. Well, our variable's name is p, and what's happening to p? It's being divided by 2, and so we're going to undo that by multiplying by 2. Do that to both sides. This goes poof. I get p on this side, and 2 times 3 is 6. So 6 equals p, and again, if we want, we can write it afterwards as p equals 6, but we do need to include this. We also need to include all the other work I've shown. And it's optional to write the p equals 6. Well, what about if it's not multiplying, but it's dividing? So let's say we have 5r equals 30. Well, then I can divide both sides by 5. And the way we show dividing is similar to what we just saw, is you use a fraction bar for dividing. So I divide both sides by 5. That undoes that, goes poof, and leaves me with an r. And 30 divided by 5 is 6. So that works out great. And again, you can do it on the other side as well. So let's say we have 12 equals 4m. Then I can divide both sides by 4 because that undoes what's happening to our variable. Our variable's m, it's being multiplied by 4, and the inverse of multiplying by 4 is dividing by 4. Do that to both sides, following my rules. That goes poof, and that was the whole reason we divided, was to make that go away, and 12 divided by 4 is 3. Now some of you may ask, what happens if we have something where it doesn't go evenly into it? So what if I had 3m equals 7, and then I divide both sides by 3, poof, that gives me m equals, well, 7 divided by 3. Well, the nice thing about that is that's just a fraction, 7/3. I need to simplify it if I can. In this case, it's already simplified as much as I can, and we're done. And generally in algebra, we want to leave our fractions as improper fractions. Let's look at another one. How about 2x equals 9, and then we divide both sides by 2. Yeah, see how easy this is? X equals 9/2. And let's look at one last one. Just make sure everybody's okay with this. Let's say we have 18 equals 4x. Well, I can divide both sides by 4 because I ask myself, what's our variable's name? Our variable's name is x. What's happening to x? It's being multiplied by 4. And then we divide both sides by 4 because we want to undo what's happening to the variable. That goes poof. We get x equals 18/4, except 18/4 is not the simplified fraction. And now be careful, this would be wrong. This would be wrong. Equals 9/2. That's wrong. Can you guess why that's wrong? It's because we have 2 equal signs on a line. So we're not allowed to do that. That is incorrect. So let's get rid of that incorrect stuff. And so the way we simplify it is we write another line with x equals 9/2. And again, some of you will want to write x equals 9/2. Notice 1 equal sign per line. Our equal signs are relatively lined up. And then we only switch sides at the end if we want to. And that's it for solving one-step equations by multiplying or dividing. All we're doing is taking the inverse.